Oh, hello, Yared. I hope you're good. Sorry I can't be in your lesson today. Um, I'm observing an interview, so I can't be with you, but we can still go through this lesson. Please watch this video. Starter is on the board. Please complete all this equation. You have about 5 minutes. Could you please pause the video for 5 minutes? Okay, welcome back. So make sure you have the correct answer. So magnesium reacting with water. Remember that the first reaction we did when reacting a metal with water, we're making a metal hydroxide and hydrogen. Let me show you the answers. So magnesium and water, magnesium hydroxide and hydrogen. For the second one, magnesium and hydrochloric acid. So we have a metal plus an acid making salt and hydrogen mash. So we're going to make magnesium chloride plus hydrogen because hydrochloric acid makes chloride. Magnesium plus nitric acid, again, metal plus acid make salt plus hydrogen. Therefore, we're going to make the magnesium nitrate plus hydrogen. Remember, nitric acid always going to make a nitrate. Then we have magnesium plus sulfuric acid. This one we need to know as well. Sulfuric acid is going to make a sulfate. So we have magnesium sulfate plus hydrogen. What's going to make sodium hydroxide and hydrogen? So if we're making hydroxide, we need to react with water. So it's going to be sodium plus water makes sodium hydroxide plus hydrogen. And what is the test for hydrogen? It is the squeaky pop test. If you put a lead splint into your test tube containing a gas, a reaction will take place with a squeaky pop. Okay, today we're going to talk about metals and oxygen. Make sure you have the title in your book as well as the date. Today is approximately the 31st of March, I think. Yes, it is the 31st of March. So today we're going to describe how metal and non-metal react with oxygen. Okay, so overall, remember this, oxygen is the gas required for combustion. If you want something to burn, you're going to react it with oxygen. No oxygen, no fire. A lot of metals do react with oxygen. Okay, only the very unreactive metal will not react with oxygen. Some of them react super fast. Some of them are going to react more slowly. Or not at all. Overall, when you react a metal with oxygen, you're making a metal oxide. So for example, here, magnesium is burning on this picture, and magnesium reacts with oxygen to make magnesium oxide. Please have the blue box in your book. Please pause the video for a minute while they're writing down this blue box. Okay, so this will work for most of the metals, so please complete those 4 equations in your book. And when you're done, on your whiteboard, can you make a list of the element and compounds? If you have a doubt, you can ask Laura. She's the specialist of the definition of element and compound. So please pause the video for 4 minutes. All right, welcome back. So make sure you have the correct answer. Lithium reacts with oxygen to make lithium oxide. Copper reacts with oxygen to make copper oxide. Iron reacts with oxygen to make iron oxide. And zinc must be reacting with oxygen to make zinc oxide. So in case you forgot, an element is a substance made of one type of atom only. A compound is a substance made of 2 or more types of atoms or 2 or more elements chemically bonded together. So in there, the elements are lithium, copper, iron, zinc, and oxygen. And the compounds are the product of the reaction: lithium oxide, copper oxide, iron oxide, and zinc oxide. So some metal react very quickly, readily with oxygen. Okay. For example, remember with alkali metals, when you cut them open, they are very shiny, but very shortly they're going to get tarnished or dull. Okay, and that's because they're reacting with oxygen in the air to make the oxide. So, for example, we did with lithium and sodium and potassium. They're going to react with oxygen to make lithium oxide, sodium oxide, and potassium oxide. Other metals need a bit of help to react with oxygen. And magnesium, for example, you have to put it in a Bunsen burner for it to burn. Okay, for the next activity, Shida investigated how reactive some metals are when they react with oxygen and made the following observation. With magnesium, the ribbon burned with a dazzling white flame, giving grey-white smoke and ash. Copper, or copper turnings, went through red and oranges and then slowly got a permanent coating of black. With iron, the iron filings glowed red and sparkled, leaving a brown-black looking solid. What I would like you to do is to think and then write on your whiteboard, then compare your answer with the people around you, then share with everyone else. Place those metals in order of reactivity based on Shida's observation. Where would sodium fit in the list? Okay, so please pause the video for a minute. Think, write, pair, share. All right, welcome back. So, I don't know, I can't see really answers, but in that one, magnesium is obviously the most reactive of those three. Okay, it did react with a very dazzling white flame almost straight away. Iron is next because it sparkled, so it's going to release more energy, and copper is the least reactive. It slightly changed color and then get the permanent coating of black. So in order of reactivity, we have magnesium, iron, and copper. We know from before that sodium is more reactive than magnesium because sodium did react with water, magnesium didn't. So if you burned sodium, it would have a very, very bright flame. It's pretty cool to see. And when you do it, it becomes so hot that it can melt the gauze we use on the Bunsen burner. Okay, for this one, I'd like you to watch the video. Hopefully this will work. And when you've watched the video, I'd like you to make notes about what are the difference between metal and non-metal oxides. So how different are the product when burning or reacting a metal and a non-metal with oxygen. Let's see if this works. That's not...
When substances combine with oxygen, the process is called oxidation, and the compounds made are called oxides. The sparks in fireworks are made by burning different metals. The burning metals are reacting with oxygen in the air and producing metal oxides. Sparklers contain small pieces of iron. When you burn the iron, it reacts with oxygen to make iron oxide, creating the sparks we see. When a sparkler has finished burning, you'll notice that the iron pieces on the rod have changed colour. This is because when the iron is heated, oxidation takes place. The iron oxide is no longer a pure metal, it is a dull, dark-coloured metal compound. When you burn magnesium in the air, in the same way that the iron did, the magnesium reacts with oxygen to produce magnesium oxide. Magnesium oxide is a dull white powder. When we add water, the magnesium oxide dissolves to form a solution that turns red litmus paper blue, telling us it is an alkaline, also called a base. So this shows us that metal oxides are bases when added to water. Some non-metals can also react with oxygen in an oxidation reaction. When burnt in oxygen, the carbon in this charcoal reacts to form carbon dioxide. When carbon dioxide dissolves in water, it forms a solution which turns blue litmus paper red, telling us that non-metal oxides are acidic.
Okay, so hopefully you made note of this. So when you react a metal with oxygen, you're making a metal oxide. If you dissolve this metal oxide in water, you're going to make an alkaline solution. Okay, so very high pH, higher than 7, up to 14. So for example, magnesium oxide is going to make a solution with a pH around 12. Non-metal oxides, so for example, carbon dioxide or sulfur dioxide, are mostly liquid or gas. And if you dissolve them in water, you're going to produce acidic solution. So for example, that's why carbon dioxide is really bad for the ocean, because the carbon dioxide gets dissolved into the ocean, increasing the acidity of the ocean. And some organisms are not doing really well with the really low pH. That's why carbon dioxide is also not good for the ocean. Please have these two blue boxes in your book. Please pause the video for a minute, 2 minutes, while these two blue boxes get written in the book. Okay, so hopefully that is now all in your book. We're going to do a quick mini whiteboard, quick check. So it's 7 questions. Please write down the simple answer to this one. We're going to check in about 2 minutes. So please take 2 minutes to answer these 7 questions, and we'll check them in 2 minutes. Okay, welcome back. So, oxides of which elements are acidic? So that's non-metals oxide. Oxides of which element are alkaline? That would be the metal oxides. What is the pH of an acidic solution? So anything below 7 is acidic. And what is the pH of an alkaline solution? Everything higher than 7 is the pH of an alkaline solution. So somewhere between 7 and 14 for alkaline, between 0 and 7 for acid. Estimate the pH of a non-metal oxide. So non-metal oxide would be acidic, so somewhere between 3 and 4. An oxide of an element is tested and found to have a pH of 3. What type of element is present in the oxide? So pH of 3 is acidic. We know that non-metal oxides are going to be acidic, so it has to be a non-metal oxide. Finally, an oxide of an element turned universal indicator red. What type of element is present in the oxide? So remember, universal indicator turned red in the presence of an acidic solution. So an acid, so it has to be a non-metal oxide. It would turn blue or purple if it was a metal oxide. Okay, right now it's time for you to do a bit of practice. So can you please make sure you all have this worksheet calling Losing That Shine? And I'd like you to answer all these questions. You have about 20 minutes. Please do your work independently. Please do your work in silence. Please be the amazing people I know you can be. All right. See you later.